Greetings, Antioch Bears. Going to talk about the summation formula today. Sigma notation, indicating that we're supposed to add some numbers. The numbers sitting in spots 1 through 26, according to this rule. We got 3 times negative 2 to the power of n minus 1. So far, we've been kind of doing it the plug and chug way, they say. You take 1, you plug it in, then you solve, and you find out who's sitting in A1. Then you move your index up to 2, plug it in, find out who's sitting in A2, then to 3, and so on and so forth. Well, if you have a low number as your stopping point, that's not such a bad method. But if you have a high number like 26, that's a terrible idea. Having to do that 26 different times leaves a lot of opportunities for a minor mistake that's going to end up throwing you off for a wrong answer. So in situations where your stopping point is very high, you need to use the summation formula instead. That reads S sub n is equal to A1 times the quantity 1 minus r to the power of n, all that divided by 1 minus r. It's going to be our job to plug in for A1, r here and here, same number, 2 different spots, and then the power of n. So as I set up my S of n and I go to plug in for A1, I notice I have a problem. There's no list of numbers to look at, so I don't know who's A1 for sure. But I know I can find out if I just take 1 and plug it in for n. If I want to know who's sitting A1, first spot in line, I just take 1 and plug it in for n in the rule. Again, I hope you guys get fast enough to where you don't have to keep writing this out as scratch work. 1 minus 1, after plugging that in, is 0. Negative 2 to the 0 power is 1, and then 3 times 1 is 3. If you're comfortable doing that, go right ahead. You don't have to show all those steps. If you're not comfortable doing that, it's okay. Keep writing it out as long as you need to make sure that you get the right answer. It looks like this. 1 minus 1 makes 0 as the new exponent. Negative 2 to the power of 0, anything raised to the power of 0, is just 1. And then 3 times 1 is 3. That lets me know sitting in spot A1 is 3. So now I have something to plug in, the summation formula. Next up, I got to do times, open my parentheses, 1 minus, and now my next problem. I have no idea what the common ratio, or the R, is, because I only see one number. I don't have several to look at. So let me go ahead and plug and chug another. I'm going to find out what A2 is. I can do that by plugging in 2 for n in the exponent expression here. Scratch work would look like this. 2 minus 1 makes 1. Negative 2 to the first power is still negative 2. And 3 times negative 2 is negative 6. If you need another number, feel free to plug in 3 and find out who's sitting in the A3 spot. 3 minus 1 is 2. Negative 2 to the second power is a positive 4. And 3 times 4 makes 12. See how it's alternating between positive, negative, positive? That indicates that our R is something that's negative. Negative what? What exactly is being multiplied every single time? Looks like it's times negative 2 every single time. 3 times negative 2 is negative 6. Negative 6 times negative 2 is positive 12, so on and so forth. So my R is definitely a negative 2. I'm going to open up a set of parentheses to emphasize the difference between the minus that's in the formula and the fact that I plugged in a negative number. Now the n. The n in this situation, summation formula, is your stopping point atop your sigma. In this case, for us, it'll be 26. All that gets divided by 1 minus r, or 1 minus, again, negative 2. Now some of you students may be noticing the back-to-back negative situation, and your brain automatically says, oh, back-to-back negatives turn into a positive. Well, that's true most of the time, except for this top situation. Okay? Anytime a number is being raised to an exponent, that's going to outrank the back-to-back negative rule, because the back-to-back negative rule is really a multiplication rule. A negative times a negative is a positive. So exponents outrank multiplication. So you need to do that first, and then worry about the minus sign. Down here, since the negative 2 is not being raised to a power, we could go ahead and change that to a plus if we wanted to. It's going to end up being 1 plus 2 on the bottom. So going down to the next line, I got my 3 out here for A1. In parentheses, I've got 1 minus, and I need to find out what negative 2 to the power of 26 is. This is where your calculator is going to come in extremely handy. If you type that in, you end up with a 67,108,864, a very large number. And at the bottom, you're going to end up with 1 plus 2, or 3. Inside the parentheses, 1 minus 67,108,864 is going to give us a negative 67108,863. Last, you would multiply 3 by this number. Whatever you got, you would divide that by 3. But if you're good enough with numbers, you may notice that that multiplying 3 and that dividing 3 are perfect opposites. They cancel each other out. So 3 times this number and then divided by this number is just going to end up right back up where we started. So the sum of those numbers is a negative 67,108,863. Further emphasizing why you would not want to do this type of question by continually plugging in over and over and over again. Hope you enjoyed it. Catch you next time.